so the last time we were here, we were discussing balancing equations. And we did these three examples. And as I think I said before, it's very important that you master this particular skill because this is important for you to be able to do some other things like solving stoichiometric type problems, right? If you remember, we said at the beginning, stoichiometry is that area in chemistry which deals with quantitative relationships between substances involved in a reaction. And the only way you can tackle those problems is, of course, you have to start off with a balanced equation. Now, that's important because of what we're going to talk about next. We're going to talk about what is called a stoichiometric factor, or simply something called a mole ratio, right? I prefer this term, so I'll be using this term more often. All right? And the mole ratio is what you would obtain from the coefficients of different substances in a balanced equation. And this is very important because if you don't have a balanced equation, then you won't have the correct mole ratio that you're going to need in order to solve these kinds of problems. So for example, if you look at this equation, which is balanced, right? The reaction between carbon monoxide and hydrogen to form methanol, right? And everything is correct, everything is balanced. There's a coefficient of 1 for the carbon monoxide, a coefficient of 2 for the hydrogen, and a coefficient of 1 for the methanol. So we can establish a mole ratio between any two of these substances involved as either reactants or products. So for example, as stated here, based on the balanced equation, 1 mole of carbon monoxide is chemically equivalent to 2 moles of hydrogen. We can also say that 1 mole of carbon monoxide is equivalent, chemically speaking, to 1 mole of methanol. Excuse me. And finally, we can say that 2 moles of hydrogen is chemically equivalent to 1 mole of methanol. All right, so based on those statements, we can write down the mole ratios as a conversion factor. So for example, in the case of the relationship between carbon monoxide and hydrogen, that's a 1 to 2 mole ratio. We can express it as this conversion factor right here, where we have 1 mole of carbon monoxide above as the numerator and 2 moles of hydrogen below as the denominator. Or you could flip this. You could have the 2 moles of hydrogen above and 1 mole of carbon monoxide below. Here we have a similar conversion factor, this time between carbon monoxide and methanol. Again, these numbers are obtained from the coefficients of those substances in the balanced equation. And the final one over here is describing the relationship between the hydrogen and the methanol, which is a 2 to 1 mole ratio, which is represented by this conversion factor. Again, these can be flipped to get the other alternative conversion factor. All right? So it's very important that you have a balanced equation to start off with so that you have the correct mole ratio, which would give you the correct conversion factor. Okay, so basically when it comes to solving problems involving stoichiometry, it comes down basically to this, right? Let's say you're given a certain amount of A and you want to find out about B, how much B would be produced or react with A, all right? Well, you have to establish the mole ratio between B and A based on the conversion, well, based on the coefficients of these substances in a balanced equation. So most problems involve determining or obtaining the moles of one substance, multiplying by the appropriate conversion factor to get the moles of the other substance. Now, things can be a bit more complicated because you may be given some additional information which allows you to calculate the moles of one substance. And down here, you could be given a question where, based on the moles of the substance, you have to determine some other things like the mass, the volume, whatever. All right, but all stoichiometry problem comes down to this right here, right? Converting the moles of one substance to the moles of the other substance based on a conversion factor, which in turn is based on the correct coefficients for these substances in the balanced equation. All right. So here is a simple example of a problem of this type. So it says when 0.105 moles of propane is burned in an excess of oxygen, how many moles of oxygen are consumed? And it gives you the equation. So fortunately, they gave us the balanced equation because they could have easily give us the reaction in words and then you could be required to figure out what the equation is. But in this case, you're given a balanced equation. So let's do this problem. So according to the question, you're given, hold on 1 minute, you're given 0.105 moles of propane. which is C3H8. The question didn't say so, but that's what it is. All right. So this is propane right here. All right. Let me just make a note of that. Okay. So, and the question is asking for how many moles of oxygen are consumed in this process. So basically we start off with what we're given. And then we multiply by the appropriate conversion factor, which in this case will be 1 mole of propane below and based on the coefficient for oxygen, you're going to have 5 moles of oxygen above. And we work this out. Oops, where is that pointer? Okay, so let me get my calculator out and work this. So it's 0.105 times 5, and the answer I got is 0.525 moles of O2. So this would be the answer. All right. So that's basically a very simple example of a stoichiometric type problem. As I said before, it's important that you start off with a balanced equation. And in this case, they gave us the balanced equation. And the balanced equation gave us the correct coefficients. And that's what we're using here to figure out the moles of oxygen given the moles of the propane that the question has provided. Okay, so much for that. So in some problems, okay, so what this is showing you here is a situation where you might be given the mass of one substance involved in a reaction, and let's say you're asked for the mass of another substance involved in the same reaction. So again, of course, you must have a balanced equation to begin with. And because the balanced equation gives you the mole ratio between any two substances, what you need to do, if given the mass of one substance, is convert it to the moles of that same substance. In other words, you have to multiply by a conversion factor which allows you to convert from grams to moles. So basically, this is the conversion factor you'll be using, where you'll have 1 mole of A divided by the molar mass expressed in grams of A, and that will give you the moles of the substance. Then you multiply by the conversion factor obtained from the balanced equation, the coefficients of the substances in the balanced equation. Multiplying moles of substance of A by this conversion factor will give you the moles of substance B, and then, if required, if the question is asking for this information, if the question is asking for the mass in grams, then what you'd have to do is multiply the moles of substance of B by its molar mass, and that will give you the mass. So this just goes to show you that, questions involving stoichiometry can come in different ways, and you have to basically be able to read the question, analyze it, figure out what the question has given you and what the question is asking for, and then, of course, you'd have to figure out how to get from what you're given to what the question is asking for, which would involve a series of conversion factors. All right? Okay, so let me just... Okay, and the point being made here is that substances A and B may be two reactants, two products, or reactant or product, right? Or and product. So basically, that is, again, something that you may face when it comes to stoichiometric type problem. Now, here's a question being asked here. Let's see what it says. It says, if we're given moles of substance A initially, do we need to convert A to grams? Well, the simple answer to that is no. You don't need to convert the moles of A to grams, because all you have to do, if you have the moles of A, then the next step is simply to convert from moles of A to moles of B. All right? And of course, using the appropriate conversion factor that you'll get from the coefficients in the balance equation to achieve that. So the simple answer to this question in this box here is no. You do not need to convert the moles of A to grams, unless, of course, the question asks for you to do that specifically. But in terms of going through the process to get, for example, the grams of substance B, there's no need for you to convert moles of substance A to grams. Okay, so I'm going to stop here. The next video will be dealing with these examples, all right? Okay, so until next time.